So in the earlier lesson, we have seen the one kind of drawback about the program, right? This is the staff, which is we are giving the communications to the customer, right? So directly we can't give the reference this staff to the customer. So if you try to give the any base class to the your child class, then the child class should be accept all the functionalities. Otherwise, in case it's not accepted, then that will be the problem. So here the problem is here the customer cannot accept the performing help task of the restaurant. So now what we will do, right? We will redesign this program. So for that, what I have taken, right? I have taken the one new file, let's say with LSP. Okay, Liskov Substitution Principle. So here under this, let's design this. Let's rewrite this logic. Okay. So first of all, let's implement the. I will take the one new class. The let's say person. Okay. So abstract. I'm taking the one abstract class because I wanted to use the person as the base class to the child classes. So I will tell you why I have taken this person as the base class. Okay. So now here, let me take the one virtual method in this abstract class. Let's say that is the show role. Okay, this one, right? So let me take the logic. Public. I'm taking the virtual and void show role. Okay, so here in this method, let's design the one statement like this is the person. Okay, simple. So now why I have written this thing in the sense this is the common behavior for all the persons. Okay, so if you go to the LSP, there are different persons, right? Chef is there, cleaner is there, customer is there. So these are the persons, right? I'm not discussing of the designation. I'm saying that these are the persons. Okay, chef, cleaner, and customer. So for that, I have taken the one class. Let's say person. So this is the base class which represents the any person. Okay. So let me collapse that, and I would like to take the class here. Okay, let's say staff. Okay. Now this staff should be inherited from the person. So now here in the staff person I have taken, right? So let me override this method, that is the show role. So I have override this method, that is the show role. So here in this override method, I have taken the one statement, this is a staff member, and this is in the same class. I would like to prepare the one more method, let's say uh, perform help task. So whatever I'm having the perform help task, right, I would like to take this method. Okay, so in the staff, let me design that as a virtual method. So like this. Okay, perform help task, I have taken this method as a virtual. You see here I have taken the virtual method, and keep in mind I have taken the this is the override method which is inherited from the virtual. This is the person related class. So in the person related class I have the virtual method, that is a show role. I am overrided that, and in the staff I have taken the one virtual method, perform help task. Okay, so this is the two things I have designed. Okay, in the staff I have taken the one overrided method, one is the virtual method. And let me give the some kind of a comment for this perform help task. This is the staff specific related responsibility, I'm feeling that, so that's why I have taken this method is over here. Okay, so now let me collapse these two classes. Now let's go to the one child class. Okay, so as usual, let's go to the here chef. Okay, so now let's take the chef here. Now chef, if you see here, I am taking the staff as a parent class. So what will be happen if you take the staff as a parent class? Then so you can design the show role as well as the performing help task. So both the methods under the this chef class, if you are going to do that, right? So now design this show role and performing help task, both the members, let's use these two methods into the chef class. Now public override help perform task first class first method. I am saying that cooking food. And next I would like to implement this show role as well here in the chef. See, keep in mind, chef is having the staff and the staff is having the person. This person is having the abstract class, that is a virtual. Okay, so whatever the I mean, so what is happening indirectly, this chef, okay, having the parent, that is the person as well. Okay, so here chef is having the parent class, that is a staff, and the staff which is having the person, and the person which is having the virtual method, that is a show role. Okay, so now I would like to prepare the this override method as well into the chef class. That's it. So here I will say this is the staff member. Again, this is staff member. Let's say chef. That's it. Now this is completed, right? So let me collapse this, and now let's design the cleaner related logic. Okay, so now take the class here. I am taking the cleaner. So cleaner is also part of the staff, right? So let me take the staff here. So like chef, let me implement these two methods. One is the perform help task and show role. Okay, let me copy this code and paste here. Same logic, right? So that's why I just copy and paste it here. And coming to the cleaner, let's give the statement like cleaning tables, and role here for the cleaner, I'm saying that cleaner. That's it. So again, I will go to the class, that is the customer. Okay, this is the main important, right? So while implementing the customer, I want to use the staff as the base member. Okay, base class. So I will use the person as the base class. Okay, so I can't implement the staff here, rather than I have to implement the person. Because of why? So staff is not customer is not the staff. Staff is part of the restaurant, right? So that's the reason. So person. So again, you can use the show role method over here. Okay. So now what I can do, right? Let me copy this show role to over here. So I can say this is the customer. Okay. That's it. So now what is happening? Whenever I'm using this, I'm taking the person, but keep in mind, here while I'm using the customer, then I can accept the member, that is a show role. So now if you see the this chef, cleaner and customer, these are the three are the subclasses, right? So if you go to the chef class, it is accepting all the members of the staff. So LSP is good. For this also Liskov substitution principle it is following, and as well as customer also it is following the Liskov substitution principle, right? So in the earlier lesson, that is not a good idea. Staff which is sorry, customer which is having the perform help task, this is completely of the restaurant related task. Okay, so now we are not using the perform related task here, so this is completely under the staff only. Okay, this is not under the person, right? So now everything is good, right? So now what we will do, right? Let's create the one program, and then we will call all these members of the staff. Okay, so for that, let's design the class along with the main method. Okay, now here, let me take the chef here first of all. So we know that staff is the parent class of the chef, right? So that's it. So now I can take the one more staff here. You see, cleaner. Okay, so cleaner also one part of the staff. Okay, that's it. Now chef, who is the chef, he can perform the task, and cleaner also who can perform the help task, right? So now here, so what are the performing tasks? Whenever I'm communicating with the chef, he is cooking a food and he is cleaning the tables. If you see that cleaner, his task is cleaning the tables task, and the chef, he is the cooking the food. Okay. So even you can showcase the roles as well. Chef dot show role, you can do that, and cleaner also you can do the show role. So coming to the customer, okay. So person is the base class of the customer, right? You can do this. But whenever I'm going to the person, you can see that show role. Okay. So because of come to the customer, it is having the only show role, right? So now if you say that, if you try to person dot, so here I will say not person. Let me give the some customer. That will be the good name. So customer, here customer, and coming to the customer, if you see that there is no of the performance task, perform help task, there is no. So because of that, this logic is not implemented under the customer. Okay, so this is good, right? So rather than, if you want to prepare the any new methods under the customer, yes, you can do. So for example, if I wanted to create a new method, let's say place order. Okay. Now, if you want to call the place order from the customer, you cannot take the instance of this, this customer instance, because of this is referenced by the person. Okay, you see that this is a person, right? So if you observe that, as of now, this person is the abstract class where it is having the only one method, that is a show role. So now if I wanted to call this place order method, okay, then I should create the instance for this customer, not the person, right? So now let's create the instance for the customer. Okay, so customer here, let's say some cus here, let's say 1 is equal to new customer, and then if you see that cus1 dot anyway place order, okay, as well as you can call the cus1 as show role. So these two methods are available under the cu1, I mean this instance cus1 related reference. So here what is happening, this cus1, so what is happening, um, this CUS, which is completely referred by the customer, and whereas this one completely referred by the person. Okay, that is the difference you have to keep in mind whenever we are calling the respective methods. So now let me put the breakpoint over here and start the application. So here the first step, chef F10. So now chef who is performing the task. So here chef, which is this reference is carrying the instance of this chef class, right? If I'm going to F11, you see that chef is performing the help task. Okay, so he is cooking the food. Now if you see the output, who is cooking the food. So then if you come to the show role, again it will go to the role of the chef here. Now again if you go to the perform help task of the cleaner, yes, you can go again here cleaner, and then if you go to the show role of the cleaner, yes, you can, you see that here right side in the whatever the logs, just observe that, as long as if I'm going to navigate into the respective methods, I'm getting the statements. So again the final one is the customer. Okay, so instance is for the customer, so directly I can go to the place order here. Again if I'm going to the show role also I can do. Next here I am taking the person related instance. So now if you go to the again show role here, this is the customer. So in this way you can execute the program without any exceptions. So once again, I'm saying that the Liskov substitution principle means that subclasses. Okay, whatever the customer, whatever the cleaner, whatever the chef, whatever. So that should be able to replace their base classes without breaking the program. So that is the main agenda of the LSP.